A 1.5-meter thick concrete wall was blown to pieces in an instant, wiping out the entire garrison inside a German bunker. 18 kilograms of explosives packed into a specially designed, cylindrical round did what would have taken dozens of regular tank shells to accomplish. Wehrmacht soldiers in nearby fortifications watched as a squat armored vehicle with a short, fat barrel instead of a proper gun slowly crawled toward their positions. This unusual tank carried a weapon capable of reliably destroying even the toughest shelters. The Churchill AVRE proved devastatingly effective against German fortifications. The arrival of this specialized engineering vehicle fundamentally changed how defensive lines were breached. The story behind its creation began on August 19, 1942, on the coast near the French town of Dieppe. Allied command launched a large-scale amphibious raid to test German defenses and rehearse tactics for a future invasion of the continent. Around 6,000 troops, mostly Canadian, stormed the beaches under the cover of tanks and aircraft. What followed was a catastrophe, with critically high casualties among the Allied units. German forces had fortified the coastline well in advance, with deeply layered defenses. Concrete pillboxes, machine gun nests, and artillery positions opened withering fire on the advancing troops. Combat engineers tasked with reaching the fortifications and planting demolition charges were cut down in droves before they ever got close. Tanks quickly bogged down in the shingle on the beach and became easy targets for German guns. By the end of the day, the landing force had suffered over 3,000 killed, wounded, and captured. The operation failed to achieve its objectives. But it was precisely this painful experience that drove military engineers to develop an entirely new type of combat vehicle. The hard lesson was clear. Conventional infantry and standard tanks simply could not breach heavily fortified positions. The military needed a machine that could roll right up to an enemy bunker, shrug off incoming fire, and knock it out with a single shot. Canadian engineers took on the challenge. Their goal was to build a weapon that would prevent the kind of devastating losses suffered at Dieppe. As the foundation for this new machine, the designers chose the Churchill Mk III infantry tank. This heavy tank had several major advantages over other models. Its frontal armor was up to 102 millimeters thick, which meant most anti-tank weapons of the time couldn't penetrate it. Its long hull and extensive track system gave it excellent cross-country mobility. At the same time, the spacious fighting compartment left room for additional equipment and an extra crew member. But the real advantage of this model was its modularity. British designers had engineered this tank from the start to carry a wide range of engineering equipment. Its technical specs supported mine rollers, bridge layers, bulldozer blades, and all sorts of other attachments. This versatility made the Churchill the ideal candidate for conversion into an assault engineering vehicle. The engineers decided to equip the new tank with a weapon of far greater destructive power. Standard tank guns, even the largest calibers, weren't suited for demolishing concrete fortifications. Armor-piercing rounds simply punched through walls without causing critical damage to the garrison inside. High-explosive shells were more effective, but still lacked the punch to breach thick, reinforced concrete. The situation called for a fresh approach, and British ordnance specialists came up with an unconventional solution. They proposed mounting a spigot mortar on the tank, a weapon with a 29mm launch rod that hurled a 230mm demolition round. Some sources cite the caliber as 290mm, but the actual projectile diameter was closer to 230 millimeters. This weapon was given the name Petard. The designers built it as a short-barreled, smoothbore system. The bore had only a few guide ridges that imparted minimal spin to stabilize the round in flight. The engineers kept the design as simple as possible, and it was precisely this simplicity that gave each shot its devastating power. The mortar round looked so unusual that it was given the designation flying dustbin. According to some sources, this was actually the official code word rather than a soldier's nickname. Tankers use this name because of the round's distinctive shape, which genuinely resembled an upside-down trash can with a long tail fin. The cylindrical body of the round contained a powerful explosive charge. Sources vary on the exact amount, with some citing around 12 kilograms of high explosive and others placing the figure closer to 8 kilograms, and the total weight came to 18 kilograms. This was far heavier than standard tank rounds and delivered enormous destructive force on impact. The way this peculiar munition worked was fairly straightforward. When fired, the propellant charge launched the round from the mortar barrel at a relatively low velocity. The projectile flew along a high arc, tumbling slightly through the air before slamming into the target with its full mass. When it struck a concrete wall or brick structure, the fuse triggered and the blast shattered the fortification. Tests showed that a single hit from this round could completely destroy a standard pillbox along with its garrison. The designers engineered the mortar to fit within the existing gun mantlet of the Churchill tank. This simplified production of the new variant and allowed existing vehicles to be quickly converted. Engineers installed the Petard mortar in place of the standard 6-pounder gun, so the external dimensions of the turret barely changed. The short, thick barrel barely protruded beyond the turret edge, giving the tank its distinctive silhouette. Inside, the fighting compartment was substantially redesigned. Since the standard ammo racks couldn't accommodate the massive rounds, the engineers created a new storage system. The fighting compartment held roughly 26 rounds for the mortar. That was fewer than the base model carried, but planners figured the sheer power of each shot would more than make up for the smaller supply. Another innovation was the addition of a 6th crew member. The standard Churchill was operated by 5 tankers: commander, gunner, loader, driver, and co-driver, who also served as the hull machine gunner. In the AVRE variant, they were joined by a specialist sapper responsible for operating the mortar and handling demolition charges. This crew member had specialized skills. He serviced the weapon and, when needed, dismounted to place explosives on obstacles. AVRE originally stood for Assault Vehicle Royal Engineers, and the name told you exactly what this machine was for. The designation was later changed to Armored Vehicle Royal Engineers in the post-war period, and that is the term most commonly used today. The designers built this variant not for tank-on-tank combat, but for carrying out engineering tasks under fire. The crew's job was to clear the way for advancing troops by eliminating bunkers, pillboxes, barricades, and other obstacles. Beyond the Petard mortar, the tank could carry a variety of engineering equipment. Special mountings allowed the installation of a small folding bridge capable of spanning gaps and trenches up to 9 meters wide. The vehicle also carried fascines, enormous bundles of wooden logs. Crews would drop these into ditches and anti-tank trenches to create improvised crossings. Various mine rollers, bulldozer blades, and other attachments turned the armored vehicle into a genuine all-purpose tool for overcoming any obstacle. Command made the important decision not to build new tanks from scratch. Instead, mechanics converted existing vehicles that were sitting in repair shops or storage. This approach significantly sped up delivery of the new machines to frontline units and saved valuable industrial resources. The designers had planned the conversion process so that it didn't require any specialized equipment. Standard repair workshops could handle the work without any trouble. As a result, by the summer of 1944, the forces had a substantial fleet of assault engineering vehicles. The tankers who would operate them went through specialized training. They studied fortification assault tactics, practiced coordinating with infantry and other tanks, and learned to accurately fire the mortar at extremely close range. Instructors placed special emphasis on crew cohesion, since every member had to act quickly and flawlessly in close quarters combat. The crews of these engineering vehicles knew they would be going in first, taking the heaviest fire and clearing the path for the troops behind them. Despite all its strengths, the vehicle had a number of serious drawbacks that posed a direct threat to crew survival. The main problem was the extremely short range of the main mortar. The heavy round had an effective range of only about 80 to 100 yards, roughly 70 to 90 meters, although the maximum range could reach up to 230 yards under ideal conditions. In practice, however, accurate fire was only possible at the shortest distances. This meant the tank crew had to close to almost point-blank range with the enemy fortification. In those moments, the vehicle was completely exposed to anti-tank guns, machine guns, and close-range weapons. At that distance, any enemy hit could be fatal, and the tankers knew it all too well. The low velocity of the projectile created additional headaches when it came to aiming. The gunner couldn't rely on the flat trajectory you get with a conventional tank gun. The mortar fired in a high arc, the round describing a steep curve through the air, making it incredibly hard to predict exactly where it would land. Every time they fired, the tankers had to account for multiple factors: distance to the target, terrain features, and wind direction. A miss meant reloading, and that process was a real ordeal for the crew. The loading procedure was incredibly dangerous. First, the crew had to traverse the turret so the mortar barrel was positioned directly over the co-driver's hatch. Then a special mechanism unlatched the barrel and flipped it upward, much like breaking open a shotgun. After that, one of the crew members popped open the top hatch, leaned out up to the waist, and manually shoved the 18-kilogram round into the breech of the mortar. The whole time, his arms, head, and shoulders were completely exposed, no armor whatsoever, making him a sitting duck for enemy fire. According to the technical manuals, the mortar was loaded by either the co-driver or the assigned sapper. Either way, the man was risking his life with every single reload. Experienced tankers tried to get through this maneuver as fast as humanly possible, spending only a few seconds popping out of the hatch before ducking back inside. But in the heat of battle, with bullets cracking past and shells going off all around, keeping your cool was extremely difficult. Crews noted that the process demanded remarkable agility and coordination, as the slightest hesitation could get you killed. Once the loader placed the round in the barrel, the mechanism swung the mortar back into firing position. The gunner then lined up the sight on the target, and the tank was ready for the next shot. The full reload cycle took about 30 seconds under ideal conditions, but in actual combat, crews spent considerably longer. Every second of delay gave the enemy another chance to knock out the stationary vehicle with a well-aimed shot. Despite all these technical challenges, the designers kept the vehicle's dimensions and weight on par with the base Churchill model. The tank weighed around 40 tons and could manage about 25 kilometers per hour on roads. Thick armor reliably protected the crew from most threats, and a powerful engine handled rough terrain without breaking a sweat. What the engineers had created was a machine combining the firepower of a siege weapon with the mobility of a battle tank. In the spring of 1944, the military began intensive preparations for the Normandy invasion. Churchill AVRE tanks were assigned to a special formation, the 79th Armoured Division, under the command of Major General Percy Hobart. This commander had assembled a large collection of unconventional vehicles under his authority, which soldiers would come to call Hobart's funnies. Besides the assault engineering tanks, the division fielded swimming tanks, mine-clearing vehicles, bridge layers, and Churchill crocodile flamethrower tanks. Hobart personally developed the tactics for deploying this unusual equipment. He understood that the success of the whole operation would largely hinge on how quickly engineering vehicles could punch through the beach defenses and clear the way for the main force. Churchill AVRE tanks played a central role in this plan. They were to be among the first ashore, tasked with knocking out enemy strongpoints and blasting gaps in the obstacles. Each crew received detailed instructions and maps marking their specific targets. Training exercises took place on specially built ranges where engineers had recreated replicas of the German Atlantic Wall fortifications. Crews rehearsed the approach to pillboxes, aiming and firing the mortar, and reloading under simulated enemy fire again and again. Command placed special emphasis on coordination between the tankers, infantry, and other vehicles. By early June, the crews had reached a high level of proficiency and were ready to put their skills to the test in real combat. On June 6, 1944, the thunder of thousands of guns tore open the gray sky over the English Channel. The largest amphibious invasion in history began with a massive bombardment of German positions along the Normandy coast. Among the hundreds of ships and landing craft approaching the shore were transports carrying Churchill AVRE tanks. By D-Day, 180 of these engineering vehicles had been converted from standard Churchill tanks, although some sources indicate that only about 121 had actually been delivered to frontline units by that date. The first tanks began unloading on the British landing beaches, codenamed Gold, Juno, and Sword. Vehicles rolled off the ramps of landing craft straight into the surf, risking stalling out or getting stuck in the sand. German machine guns and artillery were already firing, sending plumes of water shooting up around the slowly advancing tanks. The crews knew that every second spent on the open beach was a death sentence waiting to happen, so they pushed their machines forward at full throttle. Reaching the first line of fortifications, the tankers immediately opened fire. Heavy mortar rounds were launched one after another, smashing concrete pillboxes and machine gun positions. The results in combat were impressive. The heavy rounds completely demolished tough fortified structures with a single hit. German troops inside bunkers who had survived the earlier airstrikes and naval bombardment now took devastating casualties from rounds detonating right on top of their positions. The crews were most effective when Churchill AVRE tanks worked in tandem with Crocodile flamethrower vehicles. These two types of armor complemented each other perfectly, dealing maximum damage to defending units. Typically, the Crocodile would approach an enemy strongpoint first and blast it with a jet of incendiary mixture. The flames penetrated through firing slits and ventilation openings, hitting personnel inside the fortification. When a bunker's design protected its garrison from the flames, a Churchill AVRE crew would move in to finish the job. A well-aimed Petard mortar shot would seal the deal. The 18-kilogram round would smash through the fire-weakened concrete wall and explode inside, completely eliminating the garrison. After hits like these, the fortification was reduced to a pile of rubble. Infantry followed close behind the assault vehicles, occupying the cleared positions and pushing deeper into the enemy's defenses. The combination of fire and sheer demolition power had a powerful psychological impact on German soldiers. Many bunker garrisons surrendered the moment they spotted Crocodile and AVRE tanks approaching. The troops understood that concrete walls would not save them from these machines. This psychological effect significantly sped up the Allied advance and saved lives during the assaults. Churchill AVRE tanks did far more than just destroy fortifications. Crews made extensive use of the vehicle's engineering equipment to overcome the countless obstacles blocking the advance. Tanks dropped fascines into anti-tank ditches, laid bridges over bomb craters, and cleared paths through barriers. Without these capabilities, heavy equipment couldn't have pushed inland, and infantry would have lost critical armored support at the worst possible moment. At the same time, assault vehicle crews took heavy casualties. The need to close to point-blank range with enemy positions made Churchill AVRE tanks extremely vulnerable to anti-tank fire. Artillery destroyed some tanks before they even reached the beach defenses. Others were knocked out deeper inside the German lines. Yet the crews kept pressing forward with their missions, knowing that the lives of hundreds of infantrymen advancing behind them depended on their success. By the end of the first day of the invasion, the results of Hobart's specialized engineering vehicles were plain to see. On the British beaches where these machines operated, casualty rates were significantly lower compared to Omaha Beach, where American commanders had turned down the offer to use similar equipment. Churchill AVRE tanks fully lived up to expectations and proved their worth under extraordinarily difficult conditions. After the successful first phase of the operation, military leadership immediately drew the obvious conclusion. Command ordered 574 more assault engineering tanks to replace losses and make sure units were properly equipped. From an experimental machine, the Churchill AVRE had become an indispensable tool of modern warfare. On June 17, 1944, an incident occurred that would go on to become legendary among Allied tankers. During the fighting to expand the beachhead in Normandy, one Churchill AVRE ran into a German Panther. The situation looked extremely grim for the British vehicle, since the assault tank had never been designed for fighting enemy armor. The Petard mortar was built exclusively for demolishing bunkers, not for tank duels. Its round flew too slowly and on too unpredictable a trajectory to effectively engage a moving target. The Panther, on the other hand, was one of the most formidable medium tanks of World War II. Its long-barreled 75mm gun could punch through armor at over a kilometer, and its angled hull plates provided excellent protection against return fire. In a straight-up fight, the Churchill AVRE crew stood almost no chance. The tankers understood the situation, but there was no option to retreat. The commander made the call to attack. He ordered the gunner to fire the mortar, even though the chances of a weapon like that working against heavy armor were slim to none. The heavy round left the short barrel and sailed toward the target on a steep arc. According to detailed accounts of the engagement near Tilly-sur-Seulles, the gunner, Sapper Sidney Blasquet, aimed directly at the Panther's turret ring from a distance of only about 50 yards. The 18-kilogram projectile struck the target and detonated with devastating effect. What happened next caught everyone completely off guard. The force of the detonation was enough to knock the Panther completely out of action. The blast destroyed the turret ring area and likely killed or incapacitated the crew. The tank stopped dead and never moved again. A machine that had posed a serious threat to Allied armor was taken out by a weapon nobody had ever considered an anti-tank system. This incident was a vivid demonstration of the raw, destructive power packed into the Petard mortar rounds. When detonated, the explosive charge generated such massive overpressure that any vehicle within several meters suffered significant damage. Nobody had ever intended the Churchill AVRE to serve as a tank destroyer. But this episode proved that when the chips were down, a crew could defend itself even against a heavily armored opponent. After the Normandy campaign, Churchill AVRE crews continued to see heavy action across the major battles on the Western Front. They helped infantry storm fortified towns, demolished factory buildings that had been turned into strongpoints, and cleared paths through rubble-choked streets. Whenever infantry ran up against concrete fortifications or heavy barricades, these engineering vehicles provided effective support with their specialized large-caliber rounds. The versatility of the Churchill AVRE secured its important place on the battlefield. In a single day, a crew could independently destroy a fortified strongpoint, build a reliable crossing over a deep anti-tank ditch, and clear a minefield so infantry could pass through safely. No other armored vehicle of the period offered such a broad range of obstacle-clearing capabilities. The use of these specialized tanks helped save the lives of many soldiers on a daily basis during demanding combat operations. The solid base design allowed the vehicle to continue serving long after the fighting in Europe finally ended. Military engineers went on to develop several new variants based on the Churchill AVRE, successfully adapting them for peacetime duties and the specific demands of potential future conflicts. Military specialists thoroughly studied the practical experience gained from deploying assault engineering tanks during the Normandy landings and subsequent operations. This in-depth analysis later became the foundation for shaping post-war doctrine on the use of combat engineers. The machine with the short, wide barrel that lobbed heavy demolition rounds at close range had fully proven its tactical value. Building this tank was a direct result of studying the mistakes and losses at Dieppe, and its subsequent use helped thousands of soldiers survive the assault on heavily fortified enemy positions. The Churchill AVRE earned its place in armored vehicle history as an unusual but highly effective development of its era. This machine brought together unconventional engineering solutions with a clear answer to the real combat needs of ground forces. The engineering concepts built into this tank continued to influence the design of specialized military vehicles for many years to come.